Today, we're going to talk about something that causes a lot of problems in real slurry pump applications. Three simple parameters that are often misunderstood: maximum particle size, pressure, and temperature. On paper, they look like basic technical specs, but in real working conditions, they determine whether your pump runs smoothly or fails early. Let's start with maximum particle size. Most pump datasheets will tell you a number, let's say 50 millimeters. Many people assume that means the pump can safely handle particles up to that size. But in reality, it's not that simple. Slurry is not made of perfect round particles. You get irregular shapes, sharp edges, and sometimes oversized rocks. So even if your pump is rated for 50 millimeters, running it at that limit is risky. In real applications, the safe operating size is usually around 70 to 80% of the rated value. Otherwise, you may start seeing clogging, vibration, and rapid wear. Now let's talk about pressure, or more precisely, pump head. In clean water systems, calculating pressure is relatively straightforward. But slurry changes everything. Why? Because slurry is heavier, more abrasive, and creates more friction in pipelines. So when you use a pump designed for water in a slurry system, you often get lower flow, higher power consumption, and sometimes even motor overload. There's also another important trade-off. Higher pressure usually means higher velocity. And higher velocity means particles hit the pump harder. So yes, you improve transport, but you also increase wear significantly. Next is temperature, which is often underestimated. Many engineers focus on solids and pressure, but ignore temperature. That's a mistake. Because temperature affects not only the fluid, but also the pump materials and sealing system. For example, rubber liners typically have a temperature limit. If the slurry gets too hot, the rubber softens. And once that happens, wear resistance drops quickly. Temperature also increases vapor pressure, which raises the risk of cavitation. So even if everything else looks fine, temperature alone can shorten your pump's lifespan. Now here's the key point. These three factors, particle size, pressure, and temperature, do not work independently. They are connected. Larger particles require higher velocity to stay suspended. Higher velocity requires higher pressure, and higher pressure increases wear. At the same time, higher temperature can weaken materials, making them less resistant to large particle impacts. So in real slurry pump design, you're not optimizing one parameter. You're balancing all three. So how do you apply this in practice? First, don't just look at the maximum particle size. Look at the particle size distribution. Second, always calculate system head based on slurry properties, not water. And third, never ignore temperature limits of materials and seals. Here are a few common mistakes to avoid. Designing based on maximum limits without safety margin. Using water-based calculations for slurry systems. And treating particle size, pressure, and temperature as separate factors. If you want reliable pump performance, you need to think in terms of system balance, not single parameters. Because in slurry applications, small misunderstandings can lead to big failures. Thanks for watching. If you found this useful, make sure to like, subscribe, and follow for more real-world pump engineering insights.